Yes, hi. Today we will be talking about random walk simulation in Microsoft Excel. Essentially, we will have an area, a 2D area full of atoms that bounce together, and when they meet on the same location, they create a double atom molecule, so a dimer. My name is George Lungu, and my website is excelunusual.com. Please help me advertise this, okay, by any means possible, social media or links or whatever. Thank you. So let's continue with this. We will address a few questions. What options I have about modeling the motion of molecules and atoms? There are essentially two ways. The first one is using mainly VBA, Visual Basic for Applications, we will do in this project. This results in a very clean and scalable model. Also, in VBA, the code, once you learn a little bit, I'm talking about a few hours, learn the basic loops and declaration, is very fast to write, but the speed of execution can be a little bit slower. On the other hand, if you want a very fast model, later you can use mainly set formulas. Is very inflexible because you need to write, table with formulas, with sometimes complex formulas, copy paste, keep track of everything you do, and it takes a long time and it's not flexible. Again, like I said, you work with say 100 by 100 or 50 by 50. You cannot change it. You need to create a different model. For both options, you can use a chart to display the atoms and molecules, or you can just use a live self-fill, variable self-fill to display the results. Can I do this in Excel and VBA? Yes. Excel is a wonderful scratchpad style program to model science and engineering, plus is not a black box. So not being a black box, you learn a lot by using it. You create this model from scratch, from zero. And this is not only in Excel. Excel is nice. You can do it in C or C++. Those are not black boxes either, You learn a lot. But after you graduate and you go in industry, you're gonna have to use these black box programs that essentially they run by themselves. They're very good, sometimes very expensive. You need to pay high yearly rate, to use them. Oftentimes in my industry, which is electronics design, we reach the point where we pay more for software than we pay the engineer, the design engineer, which sucks. But working in a critical industry such as say aviation or even chemistry, where things can blow up, you like to keep yourself sharp, to be in control. So if you use only black boxes, after a number of years you become dull. You become dull and dumb. You become kind of stupid. So that's why it's good to always program these things by yourself, starting from zero in a program like Excel using VBA or C or C++, whatever. Is it hard to do? How fast can I have a working model? Not really. In a day or two you can have a fully working model. In this presentation we'll learn the minimum necessary to build your first animated molecular model. What versions of Excel I should use? Well, you can use anything from 97 up to 2016. I personally use 2003 or earlier. I even have a 97 version. I have a disk gotten for free at the garage sale. These old Excel versions that you will see in these presentations work exactly like the new ones, except the interface is different. So anything I do, if you have any knowledge of Excel, you can easily replicate it in the new Excel. It's very fast. The old one is very fast and very intuitive. You have high productivity. The new system of ribbon versus the old system of drop-down menus is kind of slower, okay? It's not so intuitive, and accountants, people with decades of using Excel, they complain. Okay, so use whatever Excel you have, whatever Excel version you have, just, you know, the menus are a little bit different. Now tips and advice. Don't try to learn syntax. I mean, learn a little bit, but don't try to memorize much. That's why you have Google. Personally, after building many models, I still rely 95% on Google and the syntax I wrote before. So I open, you know, I have say 100 files that I wrote, and I think which one would be similar, the closest to what I do now. Open it and copy code from there and change it a little bit, tweak it. Step by step, you know, small incremental changes. And then test it. The only thing you should memorize your girlfriend or boyfriend's birthday. Use your imagination and your scientific mind. These are much more important than any programming language. If you approach it as a game, starting with a very short code, testing, playing, and adding to it constantly, you will be able to model the whole universe in a short amount of time. Have fun. Ask questions in the comments. Help me advertise my blog, excelunusual.com. And don't forget, with some guidance and enthusiasm, you will be able to finish this in a day or two. Thank you. I will see you in the next section. In this section, we will be talking about VBA loops, and there are many different VBA loops in VBA, at least 7 with different variations. Today we will be covering just 3. I don't think we need more, even these. Usually you can use 1 for everything. We will be covering the for loop. I really like the for loop for no particular reason. The while loop, and also the do loop. So let's close this presentation and open new sheet. Here is a brand new Excel workbook, and this is the Visual Basic editor. So let's Google for loop in VBA and copy the syntax here. Copy, go here in the editor, start a new sub. Let's say sub for loop example, and here we paste what we copied there in on the website, and instead of counter, let's use an integer I. Instead of start, we start with 1, end with say 5. Actually, let's start with 0. Okay, start from 0 to 5, step increment. Let's put step is equal to 1. Okay, and next I. So that's how it looks like. Okay, so for the index I, starting from 0 to 5, step 1, you can delete this, but if you keep it, it's safer. By default is 1, and then you end it with next I. So let's declare I say dimension I as integer. Okay, I actually prefer to use long integer, because integer goes only from -127 to +127 in integers, including 0, whereas long is much bigger. You can do large simulations without running out of range. So statements. Let's look here at assigning cell value in VBA. Okay, so I go here and copy this. I found this example. Okay, so V. Because I am already in the VBA module of sheet 1, I don't usually need to do this. I can leave it. Let's see if it runs. So instead of A1, let's put B2. I don't like to run in the corner of the page on the first cell. So run the macro and you get this. Okay. Now, since I'm in sheet 1, I'm in this module, I can delete this. Okay. And delete, run it again. Okay, range. Okay. Run it again and it works. Okay. Another thing, I don't need this. I mean, it's, how do you say, is a more rigorous way to put it. You can have value, you can have formula, I think you can have string, I'm not sure. I usually don't put anything. I like clean, very simple code, though sometimes for professional programmers might look confusing, but I like to simplify as much as possible. I don't want to have mistakes creeping in because I use too many words. I know it might not be a good practice, but I like it like this. Let's run it again, see if it works. Let's put here 77. Okay, run it. Boom, 77, so it works. Another trick I'm showing you, instead of range B2, I can put just B2 in square brackets. And this is a further simplification. Okay, let's indent this properly and run it again and put let's say 33. Okay, boom. So instead of range, you know, bracket, quote, B2, close the quote, you can just use B2 in square brackets. This is very, very simple. Okay, so let's do another thing. There is something called offset function. Okay, offset function VBA. So we search this offset function, and essentially offset function is also a worksheet function, is a, you know, cell formula function. It has two arguments. It has the row here in the first argument. The second argument is column. So when you have offset 0, 0, which means is that cell, in this case A1. If you have 1, 1, it's gonna be B2. So this essentially means cell B2. So you start with A1, offset it right 1 and down 1. So let's copy this. Okay, copy. Actually, let's just copy this offset. Okay, copy, and go here and put it dot control V. Offset 1, 1 is 33. Let's put actually 55. Okay, so and run the macro. Do okay. You see this? Let's put here 3. Okay, run it again. Okay, see? Let's put this 0 I. So now it will write the number, let's say 11, starting with cell B2 and going to the right one cell at a time, 6 times. So B2 here 11, 11, 11, 11, 11, 11, 11, I believe. Okay, so let's run it. Boom. You see? Now let's put I here and put here 22. Okay, delete this. So now it will move it on a diagonal. Okay, let's do this. Okay, so it's more visible. Run. You see 22. Let's put now here a 0 and it will run it down. Okay, so it went offsetting down 1 by 1 based on this index, counting up from 0 to 5 and printing 22 here, 22, 22, 22, 22. Okay, now let's copy this thing. Copy, and create a nested loop. And let's try to fill an array here, a two-dimensional array 6 by 6 with some number, okay? So copy, Control C, and let's say here, name it nested for loop. Copy this, Control V, copy this, Control V, and let's say J here, and here J. Indent it properly. So for J from 0 to 5, for I from 0 to 5, step 1 of course. And then we put a condition, and here J, I. Okay. So what this will do, it will fill, you see I highlighted here, it will fill this area with, let's put here 7, okay? That's what this nested loop will do, okay? So you saw it, okay? It looks good. Let's do another thing. I show you this step doesn't matter. I mean, it matters, but is by default 1. So if you omit this, you're not gonna have any problem. Let's run it again. Let's put here 44, okay? And run it, okay? So you have this. Let's do another thing. It's called concatenation. Concatenation. Copy. Control V. Actually, let's just modify that one. Not fill with junk. Okay, so let's put. First, let's use a string. So I show you how it is. Let's say something. Okay. So this is a string, okay? So let's put some numbers, 2, 3, 4, okay. So, and run this, okay? See, you highlight this area, and you got this string, okay? Let's put 3ER, run it again, and wait a minute. Oh, I believe I used too much. Okay, so let's use concatenation, which means put J here. Use ampersand means and in quotation mark. Put a comma, and then close the quotation mark, and put the ampersand again. So, and I. So what you will get in each cell, you will get I separated by a comma, you will get the J separated by a comma, and followed by I, the index. Okay? Excuse me. So, let's run it. So you got this. This is the J index, the first one. The second is the I index. If we go here and put a space here, another space, you will get bigger separation. You get space, comma, space. Okay, let's run it again. This is a string here in the quotation mark. Whenever you have a string, you use quotation marks. Whenever you have a number, you just put the number, name, I, J, whatever, long integer. So okay, you see, I increase the space between them. Now, let's look into a different type of loop called a while loop. And again, I did a search, and you know, I got a result. I'm not gonna waste more time. I'm just gonna write it here. Or why I'm doing this, I'm trying to explain that you shouldn't memorize. You should just copy from existing stuff that you had, or do a search. Don't you know, clutter your mind with memorizing syntax. Let's say Control C, copy this, Control V, paste. Let's say this is while loop, and the syntax of a while loop is while J, let's say I, is smaller than 5, then 6, let's say. There's a condition, okay? And then at the end you end it with loop, okay? If you put here small l, I'm sorry, it will change it in capital and make it blue, so which means the program recognizes this as a how to say, dedicated word. So let's do this. While I smaller than 6, do this, and then you need inside the loop some sort of incrementation condition. So I is equal to I plus 1, okay? Also, you can test other things inside the loop, and let's say if this condition is true, exit while. I think end while, or I think it's exit while. You can type how to exit, force exit a while loop, but that's what it is. Let's put here 0, okay, and here put just I, okay. So the syntax, actually the while loop doesn't end with a loop, it ends with a wend. It's a special word, while and wend, okay. So let's see, this should print horizontally 6 numbers from 0 to 6. And again, I forgot something. You should put the starting number I is equal to 0. Okay, so you initialize the index here at 0 and say while I is smaller than 6, do this. So print offsetted these numbers, increment, and then end the loop here. So do this essentially 6 times. Let's run it here and see what's going on, what's happening. First delete this and then run the loop. Boom. Okay, you can put here I, run it again. You can put here 0, run it again. Okay, you can also make a nested while loop. Okay, Control C, Control V. It's nice to declare the J too. Okay, you don't necessarily need Control C, which is a good practice. Control V, Control V, and put here J, I. So while J smaller than 6, put J is equal to 0. So initialize J and I always like to start with J. Ji, while J is smaller than 6, while I smaller than 6, you put I, J here, no, Ji. J, I, and I is equal to I plus 1. Actually, let's do this. This condition, this initialization, Control C, Control X, you put it here. While J smaller than I, set I to 0. While J smaller than 6, set I to 0. Okay. Run through the I loop, end the loop, then increment J. J is equal to J plus 1, and wend again. Let me clean this a little bit. Indent this, indent this, indent this. Let's see if it looks good. So first initialize the J to 0, then start counting up. Inside you initialize I to 0, then start counting up, print it, increment here, increment. I think it's good. Let's run it. Okay, first delete this and then run this. Okay, so you got what we needed. I. Let's also put what we did before, J concatenate with a space, a comma, and another space, and then concatenate with I. Okay. Oh, there's some problem here. Maybe it needs some spaces sometimes. Yes. So let's run it. Okay. And you see what you get. This is the J, the first number is J, the second number is I. Okay. So J varies vertically, increases vertically, I increases horizontally. Okay. So so you got this. Now you can see that I said that it doesn't matter which, it does matter because for, if you use a for loop, is much easier. Okay. For nested loops and stuff, use for. While you can use it in different situations, in other situations, but in this case you see while created a code significantly larger, you know, and so that's why I like the for loop, okay, rather than the while loop. Okay, so yes, let's do let's look into do loops now. So I went here to Google and I typed do loop VBA and took the first result of the query. So let's first go here and copy this sub and Control C, Control V, and say do loop VBA, and create some space and copy this result here and see what's going on. Okay, copy, Control V, let's look at it. And let's pick the second one. They're both good, but this one has some sort of a emergency exit. So let's see, statement, delete this, exit do, and use j is equal to 0. Also increment j here, j is equal to j plus 1. And the statement we put, let's take this, Control C, and put this here. So B offset of j, and let's say j is equal to j here, and let's put a statement, if j is larger than 5, then exit do. Okay. Let's see if it works. So this one will go on a diagonal, supposed to go on a diagonal and print those values. So put the cursor here and trigger the macro, and it did what we expected it to do. Again, we can write a nested loop, but do seems not to be quite as convenient as the for loop. Okay, let's pick up this for loop. Okay, this for nested loop. Okay, Control copy and print it here. What I want to show you now is the nested for loop, say rand. So now instead of printing this ij separated by comma and spaces, we'll print a function called rnd, rand, okay, onto an array. Okay, if we do a search, and okay, So starting from 0 to 1, okay, you get this rand. These numbers, if you print them on a chart, you will find out that they all vary between 0, a hard 0, and a soft 1, which means it never reaches 1. It goes to 0.99999, and it can start at 0 and goes to 99999. Okay. If we multiply this by 2, of course, we will get twice as big, twice as much. So from 0 to 0.999 times 2. Okay. So let's print it. You see, it goes almost to 2. Let's run it again. Run it again. And set this to scale to maximum of 2. Okay. So you can see that it never touches 2. Okay. Now let's put this 3 times rand minus 1. Okay. Actually, yeah. Let's put 2. You see, this goes between -1 to 1. And also put a function called int of this, and actually let's put this 3 here. Okay, so we will need in our project a random number between -1 and 1, integer. So -1, it can take 3 values, -1, 0, and 1, because the atom can move randomly either to the right one step, to the left one step, or stay in place with equal probability. So this function int, this int is essentially a truncating function, truncates to an equal. Multiply function run by 3 and subtract a 1, and then take a truncate this, and it can give three outcomes, either a -1, a 0, or a +1 with equal probability. Let's run it again. You see. Okay. So this is the rand function. Okay, used in a 2D loop and filling out the table here. Okay.